In this video we're going to look at simplifying expressions that have fractional exponents and talk about how to simplify something that has a fractional exponent. So in order to do that we have to know what a fractional exponent means, and we look to our rules of exponents to help us there. So here's we might look at more than one rule, but here's our first rule of fractional exponents. If we have some number a to a power m over n, so the power is a fraction, that is equivalent to taking the nth root of a to the m power, or you could take the nth root of a and then take that whole thing to the mth power. So basically what we're looking at here is the numerator of your fraction is going to be a power that's applied to a, and you could either do that underneath the square root here or the nth root, or you could take the root and then apply that whole thing to the mth power. The n, the denominator, is telling us what root that we're taking. So if that's a 2, if n is a 2, we're taking a square root. If n is a 3, we're taking the cubed root, etc., etc., etc. Let's look at an example, because sometimes these rules are a little weird all by themselves. Let's look at a simple example. Let's say we have 16 to the 1/2 power. So by this rule, that would mean we could either think of this as, there's your 2, that's going to be the index, is what it's called right here. Now, I'm going to write this in red, because usually when we have a square root we don't write that 2. So, but for the sake of following this rule, I'll put it there the first time. So we have 16 underneath here, and then the 1 is in the m spot, so we could either take 16 to the first power or put the first power on the outside. In this case it's really not going to matter too much, but I'll write it out both ways. So we could have the square root of 16 and then take that whole thing to the first power. But since the square root of 16 is a nice number, and the 1, the power of 1, isn't going to change anything, basically 16 to the 1/2 power is just the square root of 16. Alright, similarly, something to the 1/3 power, that's equivalent to the cubed root of that thing, and it'd just be 8 to the first. We could write a separate little rule where instead of the m we have a 1. Something that's to the 1 over n is just the nth root of that number. Notice this is just a special case of the rule that we did at the beginning where m is 1, because taking something to the first power doesn't change it. Alright, so the cubed root of 8 is 2. Alright, let's get a little more fancy here. Let's take this one more step. What if we had 8 to the 2/3 power? Well, we still have a 3 where the n is, and we have a 2 where the m is. Let's write it out both ways and then decide which way we want to do it. So we can either do, let's call this, we'll call this option 1, and we'll call this option 2. You don't need to do it both ways. Either one of these ways is going to give you the correct answer. So we have the cubed root, and then we can either do the cubed root of 8 squared, or we could do the cubed root of 8 and then square it. Well, how do you know which one you want to do? Well, the short answer to that is it easy to take the cubed root of 8? Is that a nice number? And the cubed root of 8 is a nice number, so you might as well do it this way. You might as well use option 2. The cubed root of 8 is 2, and then if we take that to the second power we get 4. So that's kind of easy to do in your head. If we did it the other way, we would take the 8 to the second power first, which is 64, and then do the cubed root of 64, which is 4. Either way, you're going to get the same answer. Alright, so hopefully you're starting to see how these work. Let's throw in maybe some negative exponents and see what that looks like with a fraction. Alright, what if we have, how about 64 to the negative 3 over 2? Alright, well the negative in this situation should hopefully bring up another rule in your mind, which is if you have something to a negative power, that's equivalent to the reciprocal of that same thing to the positive power. So basically it's telling you to take the reciprocal. We don't want to think of this to the negative 3 over 2. It's really better to use this rule with the negative exponent to take the reciprocal and then apply the rules that have to do with the fractional exponents. That's my advice, instead of taking the m value to be negative 3, although it will still work out. My advice is to use your negative exponent rule and rewrite this as 1 over 64 to the 3/2 power, and then go ahead and just apply your fractional exponent rule. Alright, so what does that give us? Let's see. We've got 1 over the square root of 64, because the 2 right here makes this a square root. That 2 is going to go right there for your index. Now we need to decide where to put the 3. We can either put the 3 inside the square root and cube the 64, or we can put the 3 outside the square root and cube the square root of 64. Well, since the square root of 64 is nice and we can do that in our head, let's go ahead and put the cube outside. Otherwise, we'd have to cube 64. 64 times 64 times 64, get that big number, and then take the square root of it. It's going to be easier to just take the square root of 64 is 8, and then cube that. 8 times 8 times 8. What's that? 8 times 8, 64. 64 times 8 is going to be 512. So we have 1 over 512, and that's the answer. Now you can use your calculator to verify your answer. Let's see if I can pull up a calculator here. That will do that. Let's see, we're probably going to have to go to the fancier version. So if we take 64 to the quantity, well, we could type in negative 3 over 2 is negative 1.5, right? So we could take it to the negative 1.5 power. So we'll take it to the 1.5 negative power equals. Oh, that didn't. Oh, that's okay. So that right there is the decimal for 1 over 512. You know, this calculator is not giving me the answer in fraction form. Many of the calculators nowadays will. You could change it straight to a fraction form. So what I could do to verify this is take 1 divided by 512 and see if it gives me that answer. 00195. So 1 divided by 512 equals 0. It's the same number, right? And again, like I said, many of your calculators will just give you the fraction answer or allow you to change that decimal to a fraction so you can check it. All right, let's have you guys try one on your own. And maybe pause the video and see if you can make this work out. Let's try 27 to the negative 4/3. Why don't you pause the video and give this a try, and then hit play when you're ready to check your answer. Alright, so again we have a negative exponent. I'm going to suggest that we go ahead and do the reciprocal right off the bat so we can change that to a positive exponent. That's supposed to be a 4 right there. Alright, so now we're going to apply our rule of fractional exponents right here. And this is telling me that I need to take the cubed root of 27, and then I need to do the 4th power. I can either put the 4th power on the 27 or outside. I'm going to go ahead and put it outside because the cubed root of 27 is a nice number. Most of the time this is how it's going to work. The cubed root of 27 is 3. Then I take that to the 4th power, which is 81. So my answer is 1 over 81. Notice this is not a negative number. That's a big mistake people make when they're working with negative exponents, is they think it means negative numbers. It doesn't. Negative exponents mean to take the reciprocal. They don't mean negative numbers. Alright, let's look at one more last example here, and then maybe give you one of these to try. Let's say we have something like, let me change back to blue here. we have a fraction, 125 over 8 to the negative 2/3 power. Okay, so what we've got going on here is we've got a negative exponent. Again, I suggest we take care of that negative exponent. In order to do that, we need to do the reciprocal. So since this entire fraction, 125 over 8, is to a negative power, what we need to do to get rid of that negative and change it to a positive power is take the reciprocal of the base. The reciprocal of what's being taken to a power. So see what I did there? I just flipped the 125 over 8 to 8 over 125, and that allows me to get rid of the negative on the exponent. That's what this rule is saying. Notice the a is going from the numerator to the denominator. I guess you could write a separate little rule for fractions, sort of like a special case of the negative exponent rule. If you have a fraction to a negative exponent, you just flip your fraction over, and then you can change your exponent to a positive. That's kind of a special case of the primary rule. Okay, so now we're ready to do our exponent rule. Oopsie. So we're going to take the cubed root, that's the 3, of the entire fraction, 8 over 125. Again, both these are perfect cubes, so that's not going to be a hard thing to do. And then we'll take that to the second power. Let's go this way. So the cubed root of 8 is 2. The cubed root of 125 is 5. 5 times 5 times 5 is 125. And then we need to take this whole thing to the second power. So 2 to the second power is 4. And 5 to the second power is 25. So there's your answer, 4 over 25. All right, let's have you guys try one of these, and then we'll check your answer and call it a day for this video. How about, let's do 64 over 81 to the negative 3 halves. So pause the video, give that a try, and when you're ready, go ahead and hit play. Okay, so again we have a negative exponent. I'm going to take care of that first by flipping this over. Then I can write this as a positive exponent, get rid of that negative. This 2 tells me I'm going to take the square root, 81 over 64. And then the 3 tells me I'm going to take that to the third power. So the square root of 81 is 9. I think I'm going to need a calculator here. The square root of 64 is 8. And then I got to take this all to the third power. I think we did 8 to the third power a second ago, didn't we? Wasn't that 512 a second ago? Pretty sure it was. Okay, so 9 to the third power, let's see, 9 times 9 times 9, that's 81 times 9, which is 729. 80 times 9 is 720, 1 times 9 is 9, 729. So that's my answer. Now some of you might be looking at that fraction thinking, does that reduce? Should I reduce that fraction? And the numbers look big enough to where you're thinking they might reduce. But if you consider where these numbers came from, 9 to the third power is 9 times 9 times 9. That's how we got the 729. 8 to the third power, 8 times 8 times 8. That's how we got the 512. Nothing's going to cancel there. All you've got on the top is a bunch of 3's. 9 is 3 times 3. You know, you've got, this is separated here. 729 is 3 times 3 times 3 times 3 times 3 times 3. And on the bottom, you just got a bunch of 2's. I don't want to write them all out because there'd be a whole bunch of them. 8 is 2 times 2 times 2. And so basically on the top, all you've got are factors of 3. And on the bottom, all you have are factors of 2. So nothing's going to cancel there. You could write it as a mixed number, but there's no reason to do that. We'll just stick with 729 over 512. All right, well, I hope that helps in working with fractional exponents.